So there isn't much left to finish up this practice test. I just didn't want it to drag on for too long. For the next 5 problems, this table that I showed as we did the problems in section 3.6 is something you should probably have if you get to use a note card. I'm going to refer to it even though I have it memorized. So for each problem, 16, 17, 18, 19, and 20, I'm going to find the function first and then describe the transformation. Each of the functions is just based on the x squared function. 16a wants me to find f of x minus 3. Because the minus 3 is in a parentheses, I need to create a parentheses that has an exponent of 2 outside of it and put the x minus 3 in a parentheses. In function notation, if you have a minus inside a parentheses, it shifts the graph to the right. When I describe the movement, I'm just going to say right 3. I can say shifts the graph right 3, but this is good enough. For 17a, part of what I'm going to need is an x plus 5 in a parentheses with a square outside of it. I'm also going to need a negative in front of the parentheses to create my function. The negative preceding the f needs to go before I write anything. And since the x plus 5 is in a parentheses, I need to create a parentheses because the problem didn't have a symbol that worked as a parentheses. So I created the parentheses and put the x plus 5 in that parentheses. The negative in front of the f reflects the graph over the x-axis. The plus inside the parentheses shifts the graph left. So I'm going to say, for describing what this does, this graph is going to be reflected over the x-axis. And it's going to be moved left 5 units. (18a), the number that's presented to me is after the function, so it doesn't go inside a parentheses. When I go to do part A, I'm just going to keep my initial x squared function and add 2 to the x squared function. There's no need for a parentheses because the 18a only has an x in a parentheses. That plus 2, because it's not in a parentheses, is going to move the graph up. So for my answer to part B, the graph is going to be moved up 2. 19a, the x plus 2 is going to need to go inside a parentheses with an exponent of 2 when I'm trying to find each function. The minus 4 goes at the very end of whatever I had to write preceding it. That's the find the function. The plus in the parentheses moves the graph left. The minus after the function moves the graph down. So I'm going to say this graph gets shifted left 2 units and down 4 units. Last one of these, and then we'll just have the word problem. To do 20a, the x minus 1, because it's in a parentheses, needs to be in a parentheses, or if I had a square root symbol under a square root symbol, if I had an absolute value under an absolute value, the square root and the absolute values kind of work like a parentheses, but because x squared doesn't have a parentheses, anytime the parentheses has something other than just x, I need to create a parentheses. So that's the part A, that's finding the requested function. The minus inside the parentheses is going to shift the graph right. The plus afterwards is going to shift the graph up. So this is going to be right 1 and up 7. One more problem, it's the word problem. And it's the one that has the river that I usually put on the test. So a campground owner has 2,000 meters of fencing that he's required to use as he encloses a rectangular field bounded by a river. No fencing is needed on the side of the river. Let W be the width. Let's find the most area that the farmer can enclose. So this is what the campground owner can enclose. This is what the campground owner's doing. He's building 3 lengths of fence that border to a river as close as you can make a fence to a river. And I make the sides perpendicular to the river. I call them widths. The units are going to be in meters. And the side parallel to the river I call the length. And this campground owner's building 1 length and 2 widths, and all the 3 sides need to add up to the 2,000 meters of fencing that are available. Question A wants me to solve the equation that I just created for L. So I'm going to minus 2W from both sides and get L equals minus 2W plus 2,000. I want to maximize the area of this region, so I need an area equation. This region's a rectangle, and every rectangle has an area equation of length times width. That's not going to be suitable in order to get my answer, so I'm going to need to change the L from the length times width to what I know it equals to for this problem. So I'm going to say area equals minus 2W plus 2,000 times W in order to get my area equation. Now I'm going to clear the parentheses by going minus 2W times W and positive 2,000 times W. My area equation is minus 2W squared plus 2,000W. This is the equation I'm going to need to use to get my answer. In the video, I graphed one of these, and the graph would look something like this. Each point on the graph, the x coordinate is the width, the y coordinate is the area. Because I'm trying to maximize the area, I'm looking for a maximum point. That's going to be at the vertex of the parabola. And in order to find the vertex without my calculator, at least to find the x coordinate of the vertex without my calculator, I use the formula negative b over 2a. So the width that's going to give me the maximum area is the width that comes out the vertex of that parabola that I don't need to graph, but I need to know the formula. The formula to find the width of the x coordinate of a parabola from this kind of equation is negative b over 2a, where the a is the number in front of the square term. In this case, it's negative 2. The b is the number in front of the first power term. In this case, it's 2,000. So w, or the width, in meters, is going to be negative b, which is going to be negative 2,000, over 2a, which is going to be 2 times negative 2. This is going to give me negative 2,000 over negative 4, which is going to be 500. When I go to write my answer, I should probably at least write the word width. The number is going to be 500, and the units are meters, and it's not square meters until you get to the area. To do part D, to find the length, I'm going to use the length equation that I just created. Length equals minus 2W plus 2,000. And I'm going to change the W to 500. You can use your calculator if you don't want to do the math in your head. I get 1,000 for the width, the length, and that's good because I'm building 2 widths. That's going to be 1,000 meters of fencing, 2 by 500, 1 length at 1,000 meters of fencing. That will use all 2,000 meters of fencing like I'm required to do. So my length is going to be 1,000. I don't have room to write meters, so I'm just going to abbreviate it. And the last question for this practice test, find the maximum area. The easiest equation to use to find an area is area is length times width. If I know the length and the width, I might as well use it. So the area is going to be the length of 1,000 meters times the width of 500 meters. The units are going to be square meters because meters times meters gives me square meters. And I think the number is 500,000. I'm afraid to do that and commit to that forever. Yeah, 5 with 5 zeros. So that's everything for this practice test. There won't be anything on the test that hasn't been shown on the practice test. There is the remote chance that there's something on the practice test that I don't put on the test, but it can't go backwards. So, and some of the things on the practice test might not be on the test, but everything on the test will be like something on the practice test. Usually my tests are 100% the same as my practice tests.